morning everyone, I'm Kushagra, Verma, currently pursuing my bachelor's degree in aeronautical engineering from the University Department, Rajasthan Technical University, Kota. So today my topic is asteroid mining under the guidance of Professor Mohammad Shaikh. So let's begin with the first slide. So in this, the content of my seminar, we'll start with the first topic, introduction. So as we know that human population is increasing day by day, so there is a huge consumption of resources in developing countries. So minerals will be going to exhaust within the 50 to 60 years. So there comes the asteroid mining. Thus, from saving humankind, we must find new ways to provide enough resources to human demand. So there comes the asteroid mining, which is exploitation of minerals from asteroids and minor planets. Including near-Earth objects, asteroids contain raw materials like gold, platinum, silicon, nickel, iron, etc. So these were found from rocky fragment left over formation of our solar system about 4.6 billion years ago. So asteroid mining can be solved a huge consumption problem of resources and help for space exploration. So asteroids are minor planets of inner solar system. They are metallic rocky bodies without atmosphere. They rotate in orbit under the influence of strong gravitational force from the sun or planet. The size and shapes of asteroids are very significantly same, including even dwarf planets, but not the planets. Next slide. There are three classes of asteroids: Type C, Type M, and Type S. So we'll start with first Type C. The Type C asteroid has high abundance of water, and it is most commonly found, and around 75% of known asteroids are Type C only. So Type C asteroids are extremely dark in color because of the large amount of carbon. It contains organic carbon, phosphorus, and other key ingredient for fertilization, which could be used to grow food. S-type asteroids carry little water, but more attractive because they contain numerous metals, including nickel, cobalt, and more valuable metals such as gold, platinum, and radium. Approximately 70% of asteroids are this type, making it the second most common after C-type. A small 10-meter S-type asteroid contains about 650 kg of metal and 50 kg of rare metals like platinum and gold. So next, M-type asteroids are very rare but contain up to 10 times more metal than S-type. So we'll go to the next slide. So the next slide shows that the near-Earth asteroids represent the vast untapped reservoir of minerals resources. In space, usually expand the human presence beyond the low Earth orbit. Half of the NEAs are made up of the same materials and are typically rocky meteorites. These contain small flakes of nickel, alloy, and platinum metals in much more greater abundance. Typically rocks from Earth crust. And most of NEAs, near-Earth asteroids population resembles the carbonous meteorites and contain higher fraction of waters and little carbon-containing minerals. A little less than 10% of NEAs have massive mountains of pure iron and nickel. Next slide. And this is a graph which shows many near-Earth orbits have been discovered till 22nd March 2018, which is almost 18,000, and is very vast amount of asteroids are available for mining resources. As we have already sufficient data to start the asteroid mining. Next slide. Resources from asteroids. So as we investigate in the past, in 1989, the world production of iron ore reached to its peak around 928,051 metric tons. In comparing comparatively small M-type asteroids with a mean diameter of 1 kilometer could contain around 3 billion metric tons of iron, nickel, or which is around 3,000 times the annual production of 1989 disaster. And next slide is we see the platinum element in asteroids have many stony meteorites containing platinum group materials at grade of up to 100 grams per ton. Operating among pit platinum and gold mines in South Africa and elsewhere mines of grade 5 to 10 ppm. So grade of 10 to 20 would be regarded as spectacular if available in the quantity on the Earth. In next slide, we see that researchers have found out that the helium is a perfect source of fuel, extremely polite, non-polluted, and non-radioactive byproduct. It is a fuel of 21st century and it is hardly found on the Earth. It is found when the titanium is decayed into helium-3 with a half-life of 12.3. Once we extract helium-3, we can have perfect energy source extraction of helium, can generate huge profits, and have human to travel into the stellar space without worrying about the fuel. In next slide, we see that water is one of the most obvious one and key potential product for asteroid mining, as it's highly prized resource in outer space. It will be broken into hydrogen and oxygen to form rocket engine propellant. Not only that we can get the stuff back to home, but also an unbelievable, valuable commodity to sell in outer space. With the help of asteroid mining, we obtain semiconductors to make large amount of solar panel, which will work on 24 hours for supplying energy to space colonization exploration. We can make huge profit, huge number of solar panels, and make them rotate to the sun to generate huge amount of energy, which will make us type 2 civilization. We would have unlimited source of energy. We just need to transfer it to Earth. Next slide. We analyze asteroid. We analyze the asteroid whether it is suitable for mining or not. So we use the Akada Series 100 spectroscopy and radar technology, which is used to determine the properties such as asteroid chemical composition, orbit, rotation, shape, and metal concentration. The next is Archive 200 series to the H and right geostationary satellite to analyze asteroids to closer quarter. Micro propulsion and imaging technology can be obtained high resolution data in this satellite. The next is Archive 300 series focusing on the asteroids much deeper in the space. Laser communication technology is provided in Archive 300 series. So next slide we see that there are the images of Archive series 100, 200 and 300. In next slide we see mining and processing of asteroids are much more massive than operating on Earth mining. First is lost right scrapper, in which scrapping is done. Second is component silicate matrix, in which the drill and blast are cut. Silicate and ice of hydrocarbonization is done of vaporization. Silicate and metal cut and crush. In fifth we see extensive metal cut, and sixth the stripping of metal material obtained by magnetic rigs. In next slide, so we see first we crush the mineral and then we do the sieving to remove unwanted materials from mixing with the mineral ore that we that we do grinding of material ore. After grinding, we do screening and crushing of metal ore materials and separating it into multiple grades by practical size of magnetic separation. It is done by separating components of mixture by using magnetic to attract magnetic substance. Next, in next slide, we see that we see Atlas V is put into the rocket for future asteroid mining mission, which is launched from the Earth orbit. We can use the rocket of SpaceX and Heavy Falcon to launch it. Next slide, we see so the transportation is carried out by solar electric propulsion SEP system, which works on fuel or propellant provided by electrolysis of water. Solar electric propulsion system transfer to near Earth object in 1.7 years and capture the NES to lunar space into stable higher lunar orbit is about 2 to 6 years. And next we see that how steps are followed. So in how steps Atlas V capture the asteroid. In step 1, it opens the solar array wing panel. In step 2, solar panel wing opens and it adjusts itself with the help of thrust installing in Atlas V. In step 3, it starts opening and allow predictable asteroid capture back. In step 4, we see that it goes near the asteroid and capture it with crushable form to capture asteroid. In step 5, the stock inflatable asteroid capture back fully deployed and capture the asteroids. In next slide we see the mission architecture. So at step 1, Atlas is installed and launched from the ground after 400 kilometers, about 2.5 to 252.9 miles low Earth orbit, circular orbit, its two-step separation, and deployment start in Third step, spectral of mission. Fourth step is the cause of asteroid belt. In fifth step, it takes about 1.5 years, and sixth step, the asteroid operation starts. And in seventh step, it returns to lunar orbit about 2 to 6 years. In step 8, it enters to lunar gravity assist, and in ninth step, it transfers into high lunar orbits. So next we see the advantages. So it promises the resources to support human long-term prosperity. Second, it supports human expansion into solar system. Third, it deflects some threat objects. And in fourth, reduce the demand and for precious metals like platinum, gold, silver, etc. It causes no environmental pollution and no cost for space occupations. So. And now, so this is my conclusion. Next slide. So NASA reported estimated that the mineral wealth of asteroid belt can be exceed 100 billion for each of 6 billion people on the Earth. One of the asteroid would contain 300 million ton of nickel and 1.5 million ton of cobalt and 7,500 tons of platinum. The platinum, along with, have the value for more than 150 billion. Thus, if this matter carried out, it will add trillions of dollars to the global economies. And thank you. Any questions?
Yes. Isn't asteroid mining science fiction?
Exploring the alternate source deposit is not a science fiction. Harnessing valuable minerals from a practical infinity source will provide stability on Earth, and the location of source is a new concept for many. There are around 1,500 that are as easy to reach moon, and these space rocks contain a range of minerals from water, platinum, asteroids. Mining will be provided sustainable resources on Earth and will afford the ability to maintain a human presence in space.
Aren't asteroids too remote and difficult to access?
Actually, there are over 1,500 asteroids that are easy to reach as moon, and that's because they have Earth-like orbits and they have small gravity field. So we can reach them with a very little propulsion additional. It is relatively easy to depart from them and come back to Earth because there is very small gravity field and their orbits. These space rocks containing a range of minerals from water to platinum. Asteroids will be provide sustained resources on Earth and will afford the availability to maintain a human presence in space. Thank you.